Okay, so we are going to present our authorization solution for a microservices architecture at scale that we have implemented using Neo4j and OPA. OPA is an open policy agent. And as Ido mentioned before, it was very complex and significant project for us. We had a core team of 12 developers working on it. And eventually we have rolled out the solution to all our customers. So in the process, we gained a lot of insights about building the authorization solution for microservices at scale. And today we would like to share with you those insights and the lessons that we have learned. But first, let me introduce you to AppsFlyer. So AppsFlyer is a mobile attribution platform. We help developers and marketers to get insights about their advertising campaigns. So let's say you have a cool application and you want everyone to use it and to install it. So the first thing you would do, you would advertise it in different media outlets, such as social networks, maybe Google, different websites, there are different connected TV platforms. So you have a lot of different options. The problem is that your advertising budget is limited. So you need to make wise decisions so that you can actually invest your advertising budget in a way that will allow you to get the best users for your specific application. So this is where AppsFlyer helps. How we do this? We collect the information about the performance of the advertising campaigns and also about the installation of applications and user actions, and we connect the two. So we basically attribute the two so that you can get accurate insights about where to invest your advertising budget. So today, AppsFlyer is global, have 65% of the mobile attribution market. It's a leading platform in mobile attribution. We have over 100 employees that are spread across 20 offices globally. And about half of it are R&D team that is located in Israel. All of our products are developed in Israel. So we are very proud of our customers, and we are also very proud of the collaborations that we have with our partners. We collaborate with over 10,000 partners, such as media partners, campaign management platforms, campaign optimization platforms, and many, many more. And the logos that you see here is to demonstrate the scale of the data that we handle at AppsFlyer. So we send and receive more than 100 billion events daily. And we handle all of this data with accuracy, reliability, and always with data security in mind. So in this large ecosystem where we have so many advertisers and partners, we have a lot of different collaborations. And each collaboration is different with different levels of trust and different business objectives. And the authorization solution that we are going to demonstrate today, its goal is to basically provide the best control over the data for our customers and for our partners while complying with industry regulations such as GDPR.
Okay, so we came to a graph database conference, so let's talk about graphs. So we model AppsFlyer domain as a graph that's connected between the app owners, which are marked in blue, their applications, and the partners that they work with. And this model is used as operational repository for AppsFlyer. So it serves real-time flows and it's very business critical. And it is the source of truth for all AppsFlyer domain modeling, including the entity's configuration, properties, business context, and metadata. So in practice, just a moment. So in practice, the domain model was implemented over GraphDB or Neo4j a few years ago. And you can see here the main entities, as I mentioned before. But in fact, the graph is much more complicated than that and contains many more nodes and relationships that reflect AppsFlyer business context. So we use it for various business flows, such as entity configuration, ownership, privacy regulations, and privacy policies. And one of the benefits of modeling the domain over graph is the flexibility. So we can extend it to additional partners, customers, or additional business cases without actually modifying the existing graph. We just expand it with more nodes and relationships. So before we deep dive into our solution, let's discuss about authorization and what does it mean. So authorization defines the user permission. It confirms what user is allowed to take or which data is allowed to view. And it's important to distinguish it from authentication, which confirms the user identity and who they are claimed to be, using mechanisms such as username and password, single sign-on, and etc. And in our session, we are going to focus only on authorization. So this is the main focus of the presentation. So in AppsFlyer context, there is a business relationship between app owners and partners over application data. And as I mentioned, privacy restrictions and regulations that affect which data every user is eligible to view. So as a result, the authorization solutions that we need to build has to handle many complicated use cases. And I want to demonstrate a few. So every authorization query starts from the user identity that initializes the request. So you can see it here marked in blue. The access level, it can be to view the data or to manage the data. And the entity in context. So it can be, let's say, user from eBay. He wants to view eBay iOS data. And the context of AppsFlyer feature, which feature he wants to view. So let's say he wants to view cohort report or fraud data. This is features in AppsFlyer. And this starts very basic from user or from the app owner, but it can become very complex if you use users from other entities, from other accounts that want to view data, and they are limited to a certain data source. So if you look on the responses, a response can be very simple, like the user is not allowed, and it can be a user is allowed, but it can become more complex. For example, to enforce some data limitation. So in the third row, the user can only access data from United States. Or in the fourth row, the user can only view Facebook data. So now we'll deep dive into the authorization solution that we built in AppsFlyer. It contains of two main parts, modeling the authorization data over GraphDB, and the microservices architecture that actually enforce it. So before we deep dive into it, so before we start implementing this project, we already have domain modeling over Neo4j GraphDB. And some part of the permission authorization data was spread over it, over some properties or additional nodes, but it wasn't structured. It was just like a best practice as the engineers implemented. And when we came to this project, we had a debate if we want to move the authorization data to other source of information or keep it on the GraphDB and reorganize it. And we decided eventually to keep them together on the same graph, but a little bit changed the model. And I want to show you today the benefits and why it's so natural to combine together authorization and domain model data. So let's start with the domain model of AppsFlyer. A very simplified version for this presentation. So the core node is the account, which can be an app, like app owner or its partner. And every account has one or more users assigned to this account. And every account owns multiple apps. It can be, let's say, the iOS app of or let's take eBay, it's their iOS app, or and their Android app, and if they have multiple, let's say, gaming company, they can have many apps, and they are organized in some group of that's called app group that's organized them together. And now I want to show you how we expanded this domain model into to be a repository for authorization data. So we already have two important components of the authorization process inside the graph. So we have the user context, here in red, and the what, which resource it tries to access, the app. So we need to expand it to support the entire use cases we demonstrated. So the first thing that we do is to add a node called permission to the graph that represents the access level of the user. And then we add another node called capability, which represents features in AppsFlyer domain. So let's say cohort report or fraud and etc. And then we have a model that supports queries starting from user that includes the context and the features. And the last thing that we need to add is the data filters that can represent data policies and restrictions that limit which data the user is allowed to view. Now I want to show you some of the advantages of such modeling and what capabilities it includes. So let's demonstrate some use cases. So let's say you want to add a new app to the account. So we just add it here under the app group, and automatically all the users that already have permission on this group get the permission on the app. So we get extendability to new entities without actually changing the authorization data and managing them together. Just a moment. And another benefit is the ability to support role-based access control over the graph. So let's start from the graph that we had before, and let's say we want to allow our users to control their permission via roles, which give them much better user experience. So what we do is just remove the user entity and replace it with a role entity, and the user still belongs to the account. And now the user is assigned to a certain role. So and all the permission are managed by roles. So we get role-based access control that's managed the permission on the graph. And this opens also the door to extend the graph and add new users. And if we add a new user, you automatically get all the permission assigned to the role. So we are now managing the permission based on roles and not based on single users. Another advantage of this modeling is the native support for certain entities' life cycles. So if you want to make changes in the graph due to user activities, the authorization data is automatically updated. So let's take an example. So let's say the accounts stop having an app, they remove it from the App Store, or they don't want to collect data on it anymore, so they just remove it from the app group, and then all the permissions are automatically updated. And the user now doesn't have access to the app. So we managed together the life cycle in single source of truth of the domain model and the authorization data. And let's say there is a user that leaves the company. So now the user is not assigned to the role, and the authorization data remains stable, nothing changed. But just this user have no permission now on every app. Finally, this modeling also creates very efficient authorization queries just as a graph traversal. So let's say we have a user that requests to view a certain feature on an app. So we just anchor on the requested user using like Neo4j index. And then we traverse over the graph to find the path to the application and to the capability. And the path already includes all the information required for authorization response. So we have the permission, the access level, and the data filters that's applied to him. So we get very efficient authorization query starting from the user and a path to the required resources. So to summarize this part, we demonstrated some of the advantages of modeling together authorization and domain data over GraphDB. So we get role-based access control, we get automatic extendability to new entities, and a consistent entities lifecycle, and also very efficient authorization queries, which is very important to serve users' requests on a real time. Now let's deep dive on the other part of the solution.
Thanks. Okay, so now I'll talk about the evolution of the authorization architecture of the solution of the authorization and how we scaled it from 10 microservices to more than 800 microservices. So when we had AppsFlyer started as a small company, we had less than 10 microservices, and the authorization logic was very simple. So the rules were very simple, and the way it worked is that, let's say we have a microservice that got the request from a user, and we need to authorize it. So it will call the permission management, which is managed on top of Neo4j, as Ido explained, the domain model and the authorization model. And the service will get the permission definition, and then we'll run very simple authorization logic. Now, if you look at this diagram, you can notice that in each service, there's a box of authorization logic, okay? So this works when you have like small number of services. But a few years back, we had one of the major partners changing his data privacy terms. So as a result, in order to comply with these new rules, we had to modify the authorization logic in almost all microservices. Okay, so it was a major project, pretty painful to verify, first to fix all of the services and then to verify it. And what makes it even more painful is that we already had more than 800 services. So it was like a very painful project. And when we completed it, we understood that this kind of architecture is just not sustainable, and we have to think of a better solution, of a better architecture for our authorization solution. So before I present our new solution and how our new architecture, I'd like to talk a bit about the key components of this architecture, which is called Open Policy Agent. So Open Policy Agent is a unified framework for managing policies. It's part of CNCF, Cloud Native Computing Foundation. It has very flexible scripting language called Rego that allows to write very flexible, and it's pretty easy to write different authorization rules, different rules. And it also provides an evaluation engine. So you can write these policies in Rego, and the evaluation engine that they provide can help you to evaluate all these rules. Now, you can write different kind of policies, not necessarily for authorization use cases, but when you do this for authorization, there are like two components to OPA. One is the policies, which are written in Rego, and another one is data. So for authorization, the data will include the predefined definition of the permissions. Okay, so based on the definition of the permissions and the policies, OPA will evaluate the authorization rules. So now I'll share with you like the process of how we build the new solution. So first, when we started to rethink our architecture, we looked at the authorization process and what are the steps that are included in this process. And we came to this conclusion that when a user is requesting to authorize, when a user requests something from the microservice and we need to authorize the request, the first step is to run this authorization logic to decide whether the action is allowed. The next step is to enforce this authorization decision. Enforcing the authorization decision means to prepare the data for sharing. It could be maybe masking some of the data or excluding some of the data based on his permissions. And once the data is prepared for sharing, it can be shared with the user. So the important insight here is that there is a separation between these two steps: the authorization logic, which makes the decision, and the enforcement of the decision. And what we understood is that both these steps do not necessarily have to happen in the microservice. So if you remember, in our old architecture, we had these services, and we had authorization logic box in each and every service. So using this insight, we actually changed the architecture so that the authorization logic is now part of the decision engine. And if we need to change some privacy, data privacy policies, or some collaboration between our partners and our customers changed, we don't have to change every microservice now. We can actually modify it in one place. So I'll drill down a little bit more how the solution works and how we have this control plane and data plane. Permission management is the heart of the system. So it's implemented on top of Neo4j with this graph of entity, of domain model, and the extended graph of the authorization. And when a user modifies the permission, he basically talks to the permission management and updates the definition in Neo4j. Now, data plane is something that makes the decisions at runtime. So it has to be very quick, very efficient. OPA is in-memory rules engine, so the evaluation works really quick. And when a service gets a request from a user and he needs to authorize this request, the decision engine makes the decision and the service enforces the decision that is made by the decision engine. So this is the data plane of the solution. Now, how is it connected together? So the permission management, that is the source of truth, exports the definition of the permission to use S3 storage, and then the decision engine can actually load up-to-date definition and use it at runtime when making the decisions. Now, when a user, let's say administrator, goes to permission management and modifies the configuration, the permissions, then first we export, we update, of course, the graph in Neo4j. Then we export up-to-date permissions to S3 and fire the change event. So the decision engine, which is a cluster for scalability, each of the decision engines get the change event and can reload up-to-date configuration of the permissions. So this, once the permissions are changed, it propagates to the decision engine really quickly. So this was the architecture. As I said, it's nice, very pretty. Sorry, it's a simple diagram. It looks very simple with a few boxes, but it's a very complex solution, especially when you need to support more than 800 services, and the solution needs to be scalable and performant. And we obviously had some challenges on the way. So the first challenge, or the design decision that we had to make, is whether to use the decision engine as a central service or use pattern called sidecar. So sidecar is a pattern that means that the service, that the decision engine is embedded inside the microservice. And in order to get to the decision, we had to consider different trade-offs. So the first trade-off is related to performance. So obviously, when you use a centralized service, you have additional hub for every authorization request. So when a microservice gets a request and it needs to be authorized, it needs to be, you need to call the over the network another service, and you pay for it in performance. Unlike a sidecar, which is local to the service, so it's quicker. The problem is that if you use sidecar, you have to fan out the policies every time there is a change in the policies, or every time there is a change in the permission definitions. You have to fan out the changes to all of the sidecars, which could be pretty challenging, and also it can create consistency challenges because it takes time to fan out to so many microservices. It's possible that maybe even because of availability, some of these services got the up-to-date definition and some others maybe at some point didn't get it yet. So it can create inconsistencies temporarily. Another trade-off that we thought about is scale. So when you have a centralized service and you have so many other services authorizing the request, you need to deal with larger scale, and it also can pose some memory constraints because OPA is in-memory rules engine. On the other hand, if you use sidecar, then it's like distributed by definition. You don't have scale issues. But if a certain service still need to evaluate a lot of authorization rules, then still there can be memory constraints, and partitioning the data for a sidecar would be more challenging than using a centralized service. So there are many trade-offs that we had to take into consideration, and eventually currently we have a centralized service because as far as performance, we optimized policies and we got pretty good behavior that is sufficient for our use cases, and we didn't have to deal with the fan-out complexities. But it's possible that as we scale even more, we'll reconsider the sidecar pattern.
Okay, so the next challenge we faced is around how to manage the entity's metadata on the graph. So we have properties on the entities such as, let's say, application on the right, app ID or app name and description. And in the beginning, it was very convenient and neutral to just model them as properties on the nodes. And it started very nice, but then we scale up and we have a lot of properties, as you can see here, and there are many more on the app. And this creates many issues. The first one is the lack of scheme. So we get one app that has certain properties and one app which was created older that have other properties. So we have to evaluate everything in runtime. And the second issue that's latency. When we start to query app, and there are very common properties that we typically need, such as app ID or the name, so we got high latency due to all of the other properties on the app that are barely in use, just in one flow. And the last one is just to extend it, we have to code everything. So if you want to add a new property, we have to go to the service that's right there, to the Neo, and update the property, and to the service that use it, and etc. And today, we want to allow other teams to expand the graph and to have some kind of configuration as a service. So there are many teams in AppsFlyer that hold information about app or account, and they manage it now in their database, but they want to have it unite on one database that creates like a central user experience. So how to extend it and support it at scale and without scheme is a challenge, and we're now considering if you want to split it to a few nodes or maybe move it to other database. So this is the second challenge that we faced. And the last challenge is the challenge of adoption. So it was nice that we built a new service and a new system, but one of the important aspects is to actually use it by others, especially like when all the microservices in AppsFlyer have their authorization logic inside the service. So the new system is not just replacing like one REST API with other API, but it's a change of paradigm. Meaning now the services have to remove their authorization logic and delegate it to our centralized service or the policies. And so far what we did is mostly show many examples as we can, create Swagger documentation, and etc. But now in order to scale it better, we are starting to debate, and we started to do POC of implementing some kind of SDK, so users can just call the SDK to validate the permission and have SDK to update the permission, like to move the policy to the authorization logic. And maybe some kind of back office that allow, let's say, product managers to view all the permissions, to add permission of new feature they develop in AppsFlyer, and to manage it in scale. So to recap, so AppsFlyer domain modeling is a collaboration between app owners and partners over application data. And we discussed what is authorization in general and what does it mean in AppsFlyer context. And we demonstrated how we model it over GraphDB and the microservices architecture that's included the decision engine that enforces the policies. And our main challenges now are around scale, this process, and the maintainability, how to allow other teams connect to the graph and the solution without actually need us to code everything. I hope we managed to show today a unique use case for GraphDB and Neo4j, used as an operational repository and for real-time flow and authorization data, and how combine it with open policy agent can serve as a powerful authorization engine for microservice architectures. And we were happy to answer any question about it. So thank you for coming to our talk. And last point, if you want to read more about our solution, we have this blog written by Olga in our engineering blog. You can scan the QR code and read everything. And thank you for coming.
Thank you.
Questions?